Cool. Welcome all to another Instance Gateway meeting. Just a reminder, this is being recorded and uploaded to YouTube, so behave accordingly. And we are acting under the CNCF Code of Conduct. Sweet. So with that out of the way, I know Abdullah shared the inference gateway algorithm, some of the testing that him and Kaushik have done. I'd love to dive into that. Before, I really want to get a quick consensus. I don't want to leave, take any more time on naming, but just if you hate these names, say something. Otherwise, I will assume silence is in agreement. So we want to name the use case LLM service and the backend pool LLM server pool. Gonna give it 5 seconds. If you hate it, absolutely hate it, please let me know. Otherwise, I'm running with this and we're implementing. Awesome. I love it. Cool. I hope to not talk about this for a long time. Sweet. With that out of the way, I will hand it off to either Abdullah or Kaushik to talk about the algorithm. Please take it away.
Kaushik, you wanna do it?
Yeah, thanks, Kellen. So let me share the document somewhere. Okay, I found it.
All right, I made you a co-host. You should have shared privileges.
Yes. Can you see my screen?
Yes.
Okay. So let me quickly go over. I think Abdullah shared it on Monday, so we may not have. Most of us may not have seen this or read this. There's a lot of material here, but what we have done here is we are proposing an LLM scheduling algorithm. Actually, we are proposing multiple algorithms. Each has its, and we discussed the trade-offs. And this is the main takeaway from this that we have after experimenting with various algorithms that have been proposed here. One is that queuing is critical to achieve the API goals. So one of the major challenges that we are trying to address is we have multiple latency objectives, and how can we satisfy all of them for different use cases? Number one, and number two is what do we do when we cannot satisfy those SLOs, those latency targets? And one of the key takeaway from our analysis so far is queuing is critical to achieve the API goals, and it is likely that we need to implement it from the beginning. Number two is it seems we tried various techniques. Please read over them, but simple scheduling techniques based on KV cache utilization seem to be quite effective. And we should probably rely on that in our initial implementation of the scheduling algorithm. And number three is scheduling based on predicting the output token latency is not straightforward. This is something that we invested a lot of time in. And the simulations didn't show that we can successfully predict this information, but we may revisit this later. These are the major takeaways. This is a living doc. We will update as we do more analysis. But this is a brief summary of what we have found so far.
So before moving forward as well, I would like to hear from the community, does this align with the community's experience? If anybody on the call went through this, and if they would like to call out something different here, that would be great.
Sorry, this one.
I have a question kind of to the community. The SLO metric we've kind of been using roughly has been average output token latency, which includes the prefill time. So basically, if we have 10 output tokens, we divide that by the total request time, and we use that metric. I know TTFT and TPOT are more commonly used. I kind of would like to hear from folks doing this, Jiashin possibly. What SLO metrics do you use when you're measuring your LLM service? Is an aggregated one? Is there one simple one that we could rely on? What are your thoughts?
Yeah, I think to ask, I think we commonly use like queuing time, and the TTFT and TPOT. Sometimes we generate another like metrics, combine the TTFT plus the TPOT, the interval like the token output. But overall, I think that's good enough because sometimes the TTFT contains the queuing time. We just split that part off, just calculate the preview time plus the first token generation time. I think overall, I think it covers the entire like request lifecycle. That should be, yeah.
And like again, I would like to go back to the question of do the high level conclusions here, not conclusions, like summary, align with your previous experiences? Does it sound like a reasonable path forward to first rely on KV cache utilization, for example? Did you find that queuing is absolutely essential here in achieving like SLO goals?
I think it kind of makes sense, but technically, I think based on like what metric itself is just the different algorithms, right? Like KV cache can reflect some of the status, and I think only my comment on the third one, the scheduling based on the like the output token prediction is not straightforward. I think that's true, but it depends on the scenarios. For some vertical scenarios, I think it's very easy to predict the output length. But if that's a common if that's a based model like shared by different tenants and it probably have different scenario against that model, that's kind of hard to do the prediction. And I know there's some like profiling tools like I think MLC 24, like Microsoft have a paper called Video. They do some profiling and also do some prediction as well. So but from the like system perspective, I think that's not straightforward for sure. But later, I think that's still do have some potentials if we unlock the model-based like solutions into the scheduling algorithms. Yeah.
Okay, and here, like, it's not like directly using output, right? Like it's mentioned here, it's output token latencies, like, and part of it is accurately predicting the the output length, right? So maybe we don't really need to predict the output length accurately. If we predict it like good enough, it might still be like effective.
Yeah, right. I think that's true. Yeah. Yeah, I think overall looks good to me. Yeah.
Any other question or?
Do you want to go through the two definitions that we have, Kaushik? And so we were trying to define two parameters, which is like to inform our algorithms. One is expected latency, which what we're discussing now, how to predict the expected latency of serving a request. And the other one is we're calling like pseudo cache utilization, not exact cache utilization, KV cache utilization, but it's something a bit more generic.
Let me, there are three main metrics that we are using to drive scheduling decision. And typically it's one or the other. First is the KV cache utilization, which I guess we all understand what that is. Second is expected latency, where we are trying to predict beforehand what is the latency I expect for this particular request if I send it to a particular model server. and we are estimating it based on past behavior of the model servers with regard to past requests that it handled. And number 3 is what we are calling pseudo KV cache utilization, which basically is a modified version of KV cache utilization, where we take into account both the requests that are pending, basically that are waiting to be served or queued in the model server. And we are also taking into consideration the expected output length, because we know that those will eventually take up the KV cache utilization. So the algorithms that we have considers either of one of these 3 to make routing decisions. And the hardest that we found to work with is expected latency, because it's very noisy and hard to predict, especially at high QPS. Any comment anybody has on these? No? Okay. Yeah. Maybe I can briefly go over how we do the expected latency calculation. What we do is we look at past. Basically, we divide into 3 parts, right? There's the prefill latency, there is the decode latency, and there is the queue time. And prefill latency, we look at past prefill latency in the past window of around 30 seconds, and that's tunable. And we look at the request input length. We look at the past 30 seconds decode latency per token, and then multiplied with the expected output length. And for the queue time, we just look at the past queue time of the recent requests, and we just add them together to get the expected request latency. And based on that, we make the routing decision. For example, if our target latency is X and I see the expected latency is less than X, then it's a reasonable candidate to route our request to that particular model server. Any question?
I think I've missed some of the details along the way here.
Yes.
Do you maybe have you already covered if there's a bucket of time that you're basing these averages on? W seconds, okay, all right. Yeah, okay, and then do you? I guess there's also a max size of the queue, after which point you just start dropping requests.
Oh, wait. So that is what I discussed here in the expected latency section is not here. It has nothing to do with queuing at the gateway. This is just how do we predict the expected latency of a given request in the model server. Queuing comes later. We discuss it in a separate section of how to queue at the model server. The queue I'm talking about here is the queue length that I'm talking about here. Like when the expected latency is basically the expected queue time. This is the queue time at the model server, not the queue time at the gateway.
Oh, yeah, because it seems like you would have to take into account when you're trying to hit an objective,
yes,
if the extension had already queued.
Yes.
So
Okay.
that's at the time we're trying to make a decision on a request. So the request was in the queue at some point, but then now it's at the head of the queue in the gateway. Now I'm trying to make a decision on it.
Yes.
And then, okay, if I send it to model server X, what latency should I expect from that model server? Jashin?
Yeah. A quick question. So it seems all the latency, like prefill, decode, or like those use the like static way, and the queuing time here is not directly use the, let's say, like average queuing time, because that's something we can get from the engine, right?
Yes.
Instead, here it use the like prefill latencies multiplied by the request. Why not just like use the average queuing time for each request instead?
Yeah, I didn't find it to be accurate, but again, actually, one of the important thing I missed talking about is how we evaluated all these algorithms. So we ran a simulation where we are basically simulating the VLLM continuous batching in the model server with latency profiles that we have benchmarked on A100 GPUs. And then we are evaluating how these all algorithms would work. I have the code pointed here. And when we ran the simulation, it seemed the most reliable way of calculating the expected queue time is just the queue time of the past, like the recent completed requests. But this is something we are still looking into. Like maybe what you suggested might be better. But from my initial analysis, it seemed it was
Didn't
not.
we change this to prefill latency multiplied by input?
Yeah, we already
request.
have.
That's what we have right now, right?
Yeah, yeah.
Not just the because the previous queue time is not a like an like I don't know, like it shouldn't indicate anything about the current status of the model server. Like the queue time is mostly related to the number of requests that are currently queued, right?
Mm-hmm.
It's not like about how many requests were queued in the past 30 seconds.
Mm-hmm. Yeah, I think you're right. So we are no longer, yeah, in my latest simulations, we are using this, where we are taking the average prefill latency per token multiplied by the input length of the pending requests. Because we know those will be prefilled first before this is getting prefilled. So this seemed to be more reliable than the recent queue times of requests.
Viva?
Hey, yeah, a question. So, does it make sense for us to share these findings with like the VLM or Triton folks and get their insights on why we are seeing this behavior that we are seeing? Maybe they could provide some further insights there.
Yeah, I think so. In fact, it would also be great. So I have this simulation code where we are trying to simulate basically VLLM, right? So we basically profile, prefill, and decode latencies, and then we simulate the entire VLLM model server, continuous batching with prefill and decode and recompute and everything. So it will be good if people can review this. Maybe we missed something here.
Sounds good. I'm actually meeting the VLM folks today, so I will bring this up and let you know. Yeah.
I'm wondering, like Yashin or any others, like did you try to implement something similar to this, like trying to predict the latency, and if you can share any insights here?
Yes, I think currently the experiment and the solutions we used, we didn't like try to predict the latency. We just do the kind of the scheduling based on the existing status. Let's say there's how many prompts is processing, right? That's all like statistics, and there's like a different like metrics we collect from the engine, but we haven't do any prediction yet. But in parallel, we have some work on the profiling. I can share the I think the paper I talked about. I think we try to do some offline like profiling on the known like workloads to see what's the like the traffic pattern. So in that part, the offline part, we do some prediction on the like the those like requests, and we're trying to do the integration later. But at this moment, there's no any like real integration with those offline profiling works. So online part still the basic routing. I mean the based on the statistics.
The profiling tries to understand for example, what is the latency that you can achieve at different batch sizes or different KV cache levels. Is that the main output of that profiling?
Yes, kind of, but with more like configurations, like the some engine specific like
Right.
configurations, like enable chunk prefill or not, or yes, just those configuration. Yeah.
And but then like when you, so that's fine, but then I think our main challenge here is that basically if we assume that we have llama 3 and running VLLM, so we can use that, but then the traffic that you're going to see is probably going to be different. Like it's the main point here is the output length, right? That you can't profile, right? Like it's something you're going to see different output lengths depending on the live traffic that's going through your gateway at the time of deployment, right? So that's the piece where things a bit get like, um, unpredictable. Does that match your mental
Yes.
model?
Right. I think the request level is hard to do that, and we have another experiment. Like most of the work are done by the time series prediction team. I think in the past they just predict the like the traffic or QPS, but in LLM scenarios trying to predict the overall like throughput tokens. But right now, it's hard to make it work with all the like auto scaling stuff. But if the traffic is I mean, if we think the traffic is kind of consistent and won't use that many like instance or like a scale up and down, so they prove they can predict the overall output token, because this is just a plot that is very easy for the time series prediction. But that's the overall like service aggregate granularity. I think we haven't done any work on the user level or like tenant level prediction yet. Yeah.
One other question that I have is maybe Kaushik, we can go through the experiment setup, and I want to validate if the like the use cases we are experimenting with actually matches things that you have deployed. Like for example, we're experimenting with two use cases, one with a target latency to 25 millisecond, the other one is 500 millisecond. Time per output, or like the average output token latency. Do those numbers resonate, or is some completely off? No, we like the in reality we're going to see a different mix of use cases or scenarios.
One quick question: the 25 and 500, that's the average or like P99?
It's average. It's what we have described in the API, basically, like the average output.
Oh, okay, got it.
Yeah.
Right. For per token, I think the 500 is
Too high.
Yeah, too high. Yeah.
Okay, but what should we experiment with, like with a mix, like 25 millisecond? What else?
Yeah, I think that, but this is it's hard to say. Like, I think if we say P99, I think 300 something, I think still makes sense. If we go back to like in average, I think probably 50 less than 100 definitely. Yeah.
Less than 100. Okay.
Yeah, these are the 25 and 500 millisecond is the target latency as defined in the API, and the algorithm tries to achieve that by routing it carefully.
Basically, the like the API, if you guys remember, is that it tries to achieve the SLO at 95 percentile. Basically, 95% of the requests should have an average latency of 25 millisecond or lower, or 500 millisecond or lower. It's not that 95% of the requests. Yeah, basically, that's so the 95 percentile is at the request level, not on the token level.
We do this in a rolling time window, right? Or does the simulation assume that you have access to all the data across the entire experiment length?
The simulation ran for, we simulated about 2,500 requests, and it is, what I'm showing here is that the percentage SLO met. So out of those 2,500 requests, how many were, how many met 25 millisecond, how many had a latency of 25 millisecond or lower, and then as I increase the QPS, it goes down. So
we are assuming a rolling time window for production style of this, right? Assuming we get everything else right.
Yeah, it has all. Yeah, I mean, yeah.
I'm curious, what length of time window would, maybe others can speak to this. What length of time window would be relevant to you as a user? Is that something that maybe we should make configurable? I assume for very early releases we would not, but I'm just kind of curious what length of time we should be aiming for. Because I know too small and your P95 might not necessarily be relevant. Too long, it could have the same issue or a similar issue. Cool. No big deal if no one has any input. I was just kind of curious.
Let me see if there's anything that stands out. This is something that we did where we had two use cases. One is critical with a target latency, and another is sheddable. And by sheddable, we mean it has no target latency. It is low priority, so we can shed it when we don't have enough capacity. And there we are basically, the way we are doing it is that we have a KV cache threshold above which, if all the servers are above that threshold, then we are dropping the non-critical requests. So this section talks about that. And then at the end, we talk about queuing and how we plan to queue. And we show here that post queuing, definitely we see much improvement in meeting our target SLOs. Yeah, I think any question, comments? Not else, I guess stop sharing now.
So I want to mention here, like our what we're thinking as next steps. So after we've done this initial work, like we would love to have the community look at the proposal. It's not like anything set in stone. It's just like, a set of experiments that we've done, and if there are new ideas, please share them. The simulation code is open. If you want to add more use cases and experiments there, that would be great. I think, Kaushik, we should have the simulation code uploaded into the LLM repo.
Yes,
so
yes,
that people can also review it and maybe add new stuff to it.
Yeah.
But our on the implementation side, with regards to the XProc, we plan to start implementing parts of it, the ones that seems to be we have to do anyways, like, for example, implementing sheddable versus critical, like the use cases, and maybe we can start discussing parts of how we will implement queuing after that, so that we achieve better, like, we can handle like SLOs in a better way, which seems that queuing is critical here to do. We will start with the simpler, like, algorithms that are based on KV cache utilization. We can always, like, iterate over that as we try to fine tune how we're doing, latency predictions. Does that sound like a reasonable plan forward?
Silent agreement.
Sounds good.
Cool.
Yeah.
Unless go ahead. I'm sorry. We are over time.
Bye.
Yeah, no, just a quick thing. Also, like, are we also looking at how does the probing behavior maybe impact this, or do we not think that the probing behavior has such a significant impact on the frequency at which the metrics are collected, for example?
We certainly have to. Yeah, we need to experiment with that. Currently, we're assuming that we're going to get the data, like KV cache utilization, from the responses of VLLM. So we are going to start with a forked version of VLLM that returns this. Kaushik, if you have anything to add here.
Yes, probing. So many of the algorithms, not all of them, but most of them that we discuss in this document is consistent with PLB. The way PLB does their probing, where they do power of 2, I think we can use something like that, or we can use their technique to do, especially the one that uses least latency or least KV cache utilization. So. But we need to add a section on that in the doc. We'll do that, about how this will work with PLB kind of things.
Yeah, just to add to it, yeah, I'm kind of experimenting with. So right now in the POC implementation, we just script the metrics periodically and kind of experimenting how frequent the interval of scripting metrics, how that impacts. So just to share some data points, like from some of the profiling, see like Llama 3 on VLLM on A100, the kind of the QPS a single model server can handle is not that high. It's like 20-ish, and once you reach that, you reach a point that it started queuing, and like you don't see any improvement in throughput. So which means kind of the sweet spot for each model server is probably like in the 20-ish, or maybe, I mean, if we add some buffer, like 50 QPS, and on average, each request arrive at like 20 milliseconds. So that's just, but looking at the metrics endpoint of the VLLM, at least in my own cluster, I got the response latency in like generally below 5 milliseconds, sometimes like a 1 millisecond, 2 milliseconds. Like the point is super fast. So it sounds like we can script fast enough. So that's just some data point, but obviously we need some more experiments. But it sounds like scraping can be sufficient, at least for the time being.
Also, you want to consider that we might, like for some use cases, we will have a lower QPS on the model server because we need to target a lower latency.
Yeah.
So if the use case is targeting lower latency, it's going to be lower QPS.
Yeah.
But so I guess there are two paths here. One is to continue to implement things based on the assumption that VLLM will return some of these metrics in its responses, and the other one is scraping the metrics. Is my understanding correct?
Yeah, we have two ways: the response header and scraping, and it seems scraping might just work.
And which means that it would not require us to mandate anything on the model server in terms of right, like
there's another way that kind of Google has this like probing mechanism where a server expected to expose a probing endpoint is expected to be fast.
Yeah.
You can probe some. I think it's like a subset of servers every time. And yeah,
where it is part of the request. So instead of scraping, it's path, like we probe and then route as part of the request flow.
Yeah, there's also two ways, like asynchronous probing or synchronous probing.
Yeah. Oh yeah, what I said is synchronous.
Yeah.
Sounds good.
Okay.
All right, cool.
Cool. All right. Well, thanks all I appreciate everyone's time, and we'll see you next week.
Okay. Thank you.
See ya.